Welcome back to MentorMe. In today's video, we are going to be talking about Boolean expression simplification. Now, this has been a hot topic when it comes to digital circuits, and Boolean expressions have been allocated to come up with K-maps, to come up with the combinational logic circuits, and so on. So let's just dive right into it. So we know the first step to simplifying Boolean expressions is Boolean rules. We're going to start off with some AND gate rules, OR gate rules, absorption law, and De Morgan's law. So these are the main Boolean rules that we will need in simplifying many of these Boolean expressions. So even though you might have been taught a vast number of rules, these are the set of rules that we will be using primarily in any of the simplifications that you will encounter. So let's just dive right into some examples and see how we are going to use these in our derivations. Our very first example is your A, C, or not A, not B, and C. So how exactly are we going to solve this? So let's just take this step by step. So first of all, you see that there's a common term. Firstly, you check if you have any common term, and you do have a common term, which is C in both these instances. Let's go ahead, take C out of the equation, and you end up with A or not A and not B. So this is the equation that you're left with. And what do you see here? Now, you see that you came from your first step to this step using the distributive law, and now you see this particular absorption law. So absorption law tells us that A or not A, B, it gives you A or B. So what you can see here is A, whatever your first common. So this term and this term are complements of each other. So if you have complements of each other and the complement has another term with an AND gate attached to it, you get the result of your original A, which was isolated, or the term that you were left here. So in simple terms, if you had a term that said B or B naught and A, you would just simply obtain B as it is, whatever the other term that was attached to the complement of B, which is A. So look at this. How do you solve what is inside this, which is A or not A, not B? So you have your A just as it is, or whatever the term that is with the complement, right? So that gives us not B. So this is exactly what we're trying to solve over here. So let me use another color. This term inside is simply going to give us A or not B. So this is your absorption law. Let me take off what I wrote over here and just make it clear for you guys that this, what we were talking right over here, is the absorption law. So using these terms, we can now come to Y, C, and A or not B. Got it. So this is what you're left with. So your final answer is going to be AC or not B, C. Coming to the final conclusion using the absorption law. Let's look at another example. All right, so the second example, we have something that looks like this. And what you can see right when you look at this term is that you can apply De Morgan's law. So just remember De Morgan's law. De Morgan's law tells us you break the line and change the sign. So just remember, break the line and change the line. So let me use another color to explain this. You have A or B with the not all together, break the line, change the sign. To break the line, only A has it, and you change the sign from or to and. So break the line, change the sign. So what if you have this? Once again, break the line, change the sign. That's exactly how you solve this. Let's dive into what we have right here. So we have y, which is going to be given by not of A and B and C. So what do you do right here? You break the line, change the sign. So even if you have three terms, you do the same thing. You break the line and you change the sign. So the and over here turns into an or over here. Break the line, change the sign, and this, you write it as it is. So there's no difference over here. So what do you see next? What do you look for next? Next, you look for any common terms between these. So looking at common terms, you see that you have a not B over here and A and B not over here. So you can get these common terms together. Just take this over here and write it down as y not A plus not B, which is the common term, 1 plus A, because this is for the B naught that you got from over here, plus not C. So now you're left with 1 plus A, which is also A plus 1 or 1. A or 1, which is given in an OR gate rule, gives us 1. So you see that the resultant of this is just 1. So you can write this one as not A or not B, because not B and 1 is just going to give us, so A and 1 is A. So not B and 1 is not B plus not C. So this is exactly what you're going to be left with. So your final answer is not A, not B, and not C. It's as easy as that. Let's actually move on to another example. So how do we tackle this problem? So as you can see, there's quite a lot of variables over here. You have not A, not B. You have not A and B and not C, or A or not C, not the entire thing together. So how do we do this? So once you look at this term, you can see that you can directly apply De Morgan's law to it, right? So applying De Morgan's law, what do? Forget about the bracket. All we have is A or not C, the whole thing not together. So this is the top not is what we apply De Morgan's law to. So we have to break the line and change the sign. You break the line, so you have the not C already inside, and that gives you another not on top. So if you do not already know, the complement of a complement gives you the same value. So not C is C. So this gives you a not and C. So if we add it to this part, you have Y, which is not A, not B, or not A and B and not C, plus not A and C. So you don't really necessarily need the dot over here, because that kind of implies that it's an AND gate over here. So let's go ahead with the simplification of this. So what do you do next? Once again, you write it as it is and look for any common terms. So do you see any common terms over here? I do see some common terms. So you have not A over here, you have not A over here, and you have another not A over here. So we can actually combine all of these together and simplify this further. And you will be getting Y, your not A is the common term, open a bracket, not B, or let me just erase this dot off, and B, not C, plus C. So that is exactly what you have here. When you look at this particular term, what does it remind you of? So this should remind you of the absorption law over here, what we discussed in a previous example. So we have the complement of B or B and the complement of C. So what does this give you? So once you look at this, you should see that the isolated term comes first, and you OR that with the term that is attached to the complement of it. So the complement B is just B. So the term that is attached to it is the complement of C. So you have the isolated term or the term that is just with the rest of the term. So this is what you get once you apply absorption law to this particular term. So now let's just go ahead and solve this. You have y, which is not a, and let's take this off. And you have within your brackets, you have this particular term instead of this. So you replace that with not B or not C or C. Now what you see over here, another familiar term. You see that C or not C are OR gate rules, right? So in your OR gate rules, you see this particular term, the complement. You have a term OR with the complement of the term gives you 1. That is just binary 1. So now how do we solve this further? You have y, you have not a, and within your brackets, this is just 1. So you have not b plus 1. Plus as in OR. So that is exactly what you have over here. But now, once you look at this further, do you see this particular law? You have another OR gate law, which is the term OR with 1. The term OR with 1 gives you 1, according to this OR gate rule. So this term also gives us 1. So now you're just left with your y, which is not a. Simple as that. Did you see how such a long combination of Boolean expressions just resulted in a simple complement of A? If you still didn't quite follow what I'm saying, I hope the next example is going to clear things off for you. Let's just dive right into it. Right, so moving on to our next example, we have another Boolean expression to simplify. So like I said before, first step is to check if you have any common terms. Next step is just see if you can move it around and do some simplification. So just see if you have any common terms that you see between these. And the simplest common term that I see is you have a b over here and you also have a b over here. So let's just move this term to the left side and you're going to have bc plus b and c naught, or a naught, b naught, and c naught. So this is just going to give us a common term b, and you're going to be able to get c or not c within the brackets, or with not a, not b, not c. So once again, like we discussed before, this term should be super familiar. The complements of each other or together is an OR gate rule, which is rule number 2, and it gives us 1. So right here, simple step, your y is going to be equal to b and 1. So b and 1 again, a and 1 is an AND gate rule that returns us the value a itself. So that's just going to return us b, or not a, not b, not c. Now what you see over here, so what you see over here is kind of your absorption law. So what does absorption law tell us? Absorption law is when you have an isolated term with the complement of that particular term and more terms, that is going to return us the value of the isolated term, or together with the rest of the term without the complement of that term. So if you understand what I'm saying, let's assume you have C, which is an isolated term. Have the complement of that term together with any other term. Okay, it does not matter whatever term you have here. This is just going to return us the value of the isolated term or with the rest of the terms. Leaving this, you drop this off and you have AB over here. So what happens when you have an isolated term or with the complement of it? So this is basically not B. You have not A and not C, but these are the rest of the terms that you really need in your result. So that gives us the isolated term or the rest of the term, which is not A, not C. That is exactly the answer you get here. Your Y is going to be equal to the isolated term and the rest of the terms that accompany the complement of that term. That is not A and not C. So that exactly is the answer. You cannot simplify it further. It was really easy. All you got to do is just simplify according to the main rules that you need, which are the AND gate rules, the OR gate rules, and absorption law along with De Morgan's law. And it is as easy as that. So if you have any other questions or any other simplification that you need help with, just drop a comment below and I will assist you. With that being said, we come to the end of the video. So thank you everyone so much for watching my video. And if this video genuinely helped you tackle the simplification of Boolean expressions, I request you to please subscribe to my channel and request for more videos like this and join with me to tackle all of the questions you have. Thank you.